Welcome to Connecting the Dots. This is continuation of series of making production ready code. In the last session, we touched test-driven development and created a few unit test cases to test API contracts for Animal Information Portal. If you have missed earlier videos, I would highly recommend to watch those as it will help to build the context about this series. I have put links to the previous discussions in the description below. Also, you can watch those by clicking on the suggestion at the top. Finally, please subscribe to this channel for more updates, and if you have any question, please mention those in the comment box below. I'll try my best to resolve those. Nice, let's get started. Before passing all the test cases that we wrote in the last video, I would like to spend some time in understanding what is continuous integration, which is generally also known as just CI, and how to set it up in our project. What does CI means? As per Martin Fowler, continuous integration is a software development practice where members of a team integrate their work frequently. Usually each person integrate at least daily, leading to multiple integrations per day. Each integration is verified by automated build, including test, to detect integration errors as quickly as possible. Most often, a feature is developed by many developers, and they often have to work on the same code base. Now imagine you and your colleague are working on the same and dependent code base. When you pulled it, it was stable and you both had the same version of the code. After working on the code, your colleague pushed his or her code changes to master, and later you pushed your changes to master. Let's assume there were no conflicts and code got merged successfully to the master. It can happen that you may unknowingly break the feature on which your colleague was working on. Both of you will not be able to find the bug till the code gets deployed to any particular environment and get tested. Without a proper automation environment, this bug can go undetected till production. It can happen, one can break the build itself. Such things are disaster, and it is very time consuming process to track breaking changes from the history. This can be prevented using CI. In this mechanism, as soon as someone pushes the changes to repository, system has to build and test the code before deploying to any environment. Only valid artifacts will be deployed. If the code fails to qualify, it will never be deployed until it is fixed. One can still do testing on the test environment for more assurity, and finally this artifact can be pushed to higher environments. Important point to note here is this CI build and test must be an automated process, else developers will see it as a waste and time consuming process. This will also act as hard condition to deploy build to any environment. A key part of doing continuous build is that if the mainline build fails, it needs to be fixed right away. The whole point of working with CI is that you are always developing a known stable code base. If you observe, it will make sense now why unit test cases and integration test cases are important in the code. You can plug these test cases in CI and ask CI tools to run these test cases. CI is very vital part of the project which helps to team work independently and continuously integrate their work to stable branch, making sure the stable branch will remain stable even after my changes are merged. Almost all known CI tools offer to validate the code even before the code gets merged to stable master. There are many CI tools available in the market. For example, GitHub Workflow, pipelines in GitLab, Jenkins, Travis CI, and there are many more. For our case, we'll use GitHub's workflow to build CI. Let's go to our code and set up CI workflow which will not allow merging to master if test cases are failing for any pull request. Also, we will run test cases once a new commit or push is done in master. This step will be helpful to prevent deployments if master is not stable. In the last session, we created few unit test cases. Let's run those test cases again just to see where we left last time. As you can see, these all test cases are failing, and these are the test cases where we are expecting a particular status code. For example, bad request or not found request. We haven't done any coding for returning these particular status codes. To create workflow in GitHub, you have to create workflows folder inside .github folder in the root of this project. I have created two workflows, one for pull request and one for master. First, let's understand what is written inside pull request workflow. First of all, this pull request.yml has YML file format. Then name is the name of this workflow. On is the required keyword which is used to specify which event can trigger this workflow. Value of this can be a single event, array of events, or document containing configuration of specific event. I have specified pull request because I want to run basically test all my unit test cases when a pull request is raised, and this is a document containing configuration of pull request event. Here I have specified whenever a pull request which is to be merged in master, then only run this workflow. A workflow can have many jobs. Each job can perform set of steps. If you define multiple jobs in a workflow, those run parallelly. To run multiple jobs in sequence, you can add needs keyword. As of now, we don't have multiple jobs to run. One point to note here is that all those jobs will only be executed if event mentioned here is triggered. In our case, we have set up one job. This is unique ID of the job, and runs on is type of machine to run the job on. The machine can either be GitHub hosted runner or self-hosted runner. As of now, we will use GitHub hosted runner. In actual project, if it is not open source project, you have to use self-hosted runners. I'll cover how to set up self-hosted runners in upcoming videos. As of now, we are using Ubuntu latest image to run our all test cases. There can be multiple steps in a job. Each step can have GitHub actions or commands to run as per this job. Uses keyword specify actions. There are many predefined actions which GitHub provides. We are using checkout and setup Java actions. I am using Java 8 to run my test cases. This can be provided using with keyword, and then the final step to run unit test cases using Maven. Similar to pull request, I have created a workflow for master. Only difference is I am triggering master workflow whenever a push is done to a master. Let's push all these changes to remote to see CI in action. We already have this branch created in the last video. Let's commit all these changes. As you can see, it is asking me to create a pull request. Let's create one. I am creating it against master. As per the configuration, it is saying at least one review is needed. But as I'm administrator, I can merge this pull request. And this is the important step. Here you can see the job that we have written is actually running. It is running the test cases that we have written. Our workflow has failed because there were failing test cases, and the workflow is complete. As you can see, these failing test cases are the ones that were failing in our local also. If you come back to conversation page, you can see it says the checks have failed because the test cases have failed. Now what we want is for a normal user who is not administrator and who has access to this repository should not be able to merge this branch or merge this pull request to master. Let's see how can we do this. I have a user. Let's add that user and give that user this permission of this particular repository. Once added, this user will get an invite on his mail, and once the user accepts it, he will be able to access this animal information portal. Let's say this user has accepted the request, and this is the view from that user's angle. When he goes to the pull request, he can see that merging can only be performed automatically if at least one approval is given. Let's give an approval. Even if the approval is given, user cannot merge this pull request because it says required statuses must pass before merging. This is the power of CI. Now you can plug any number of checks to pull requests, for example, code quality, code coverage checks to ensure only quality code is getting merged to master. For now, I'll stop here. In next session, I'll try to pass all test cases and then we can see how the workflow behaves for pull request and master. Till then, bye bye.